Hello and welcome to the channel Understanding.Concepts.Of.Physics. Hope you are enjoying the lecture series which I have been posting since past 2 months since the launch of the channel. If you have been liking so, then kindly subscribe the channel and keep following the videos in a link in a playlist. Now today we are about to solve one more numerical, which is again a pretty easy numerical. Just it would really take no time, and boards can ask this question in multiple choice questions because this is a too short a question for asking for 2 marks. Let's see how are we going to do it. Theory questions, kindly prepare it from theory. Kindly prepare from the playlist. Here we are about today discuss about the numericals. Okay, so pause the video and go through the question. And in case you have gone through this question, it's an ideal gas and it is taken through an isothermal process. So I would just like to highlight things up here. One is it's ideal gas, and it is taken through an isothermal process. So this is an isothermal process, and if it does 2000 joules, so 2000 is the data of work on the environment, how much is heat added to the system. So there is one quantity given, one information is given, process, and one quantity is something we are supposed to find out. So I have represented the data in the given form. It's an isothermal process. This actually signifies that the process is happening at a constant temperature. So if the temperature is constant, the change in temperature is 0. As the change in temperature is 0, the change in internal energy is 0. Basically, this step is the key to the entire problem. Nowhere it is mentioning about this, nowhere about mentioning. The process is given as isothermal, which signifies that the temperature is constant, change in temperature would be 0, and temperature change and internal energy actually depends on the temperature. So internal energy ka change is also 0, and they are saying that the work done is also 2000 joules. Now what they are asking is, okay, what is the change in energy? So how much energy is going to be added to it? So it's a very simple problem, but just have to apply the first law of thermodynamics. First law of thermodynamics says dq is equal to du plus dw, and dq is equal to, now du is 0. They have mentioned it's an isothermal process, so du is 0. So what remains is 2000. So dq becomes 2000 joules. So 2000 joules of energy must have been added to the system in order to gain the work done of 2000 joules. So 2000 heat is supplied and 2000 amount of work is also done. So that's it. There is not much thing about this. So from tomorrow onwards, from the next video actually, which I'll be posting it tomorrow, we'll be seeing numericals on a slightly tougher side, not tougher side, but slightly a level up. So we are going to just increase our level slightly for the questions on thermodynamics. This was a really very short question, and this can be asked in MCQs, like multiple choice questions, or maybe a one-liner answer. Thank you so much for watching. In case if you have been following the videos, subscribe the channel and keep watching the videos in a link. I am again and again saying that it's every video is having a link, so each and every the formulas which are getting it coming to 0 is basically a link where I have explained that in thermodynamics ka first law, isothermal process. So anyway, thank you for watching the video. Subscribe the channel. Bye.